Okay, so this is a video on the kinematic variables. Specifically, there are 4 variables you will see over and over in this course, and so it seems like a good time to hit them now. First one we're going to start with is a very simple one. In fact, it's the only scalar of the kinematic variables, and it's t. And t stands for time. Specifically, a time interval, not time like it's 12 o'clock right now. No, it's t as in how many seconds have elapsed from the very beginning till the end. So whenever we are looking at a problem in physics, we are mostly concerned with how something changes over a certain amount of time. That time is what we are going to define with the letter t. Because it's truly a change in time, sometimes you'll see it written as delta t. However, we generally understand that the delta is always there, so we just use the t. So simply recognize that whenever we talk about time t, we are implying the amount of time that has elapsed. Next up is velocity. Velocity is lowercase v. And you should now know that velocity is speed with a direction and is therefore a vector. Sometimes you will find subscripts that are on velocity, such as the letters, or the number 0 in this case. You will sometimes see 0, 1, 2, 3, any kind of number, or sometimes you'll see an I, sometimes you'll see an F, sometimes you'll see X, Y, Z. Subscripts don't change the fact that it's still v for velocity, though. So let's look at some of the subscripts that we're going to use in class. V sub x means velocity in the x direction. And if you remember your Cartesian coordinates, the x direction is horizontal. V sub y means velocity in the y direction. That is vertical. V sub 0 is actually pronounced V naught, and it means velocity at time 0, also known as the initial velocity. So whenever you see V naught, that's V with a 0, that means initial velocity. V with no subscript at all simply means velocity at that particular instant in time. In later chapters, we're going to use V naught x and V naught y to indicate the initial velocity in the x direction and the y direction, respectively. Now what about these guys, Vi and Vf, V sub I and V sub f? Some books actually use V sub I and V sub f for initial and final velocities, respectively, and there's nothing wrong with it. And if you choose to write them that way, I won't care, so be it if that's how you like to do it. I don't generally do it because, well, actually I'll get into that right here. The reason I don't use them is because I base velocity as a function of time. If I use V naught for velocity at time 0, which is initial velocity, I can think of multiple final velocities as they occur at t equals 1 second, so I'd have V sub 1, or t equals 2 seconds, V sub 2, or t equals 3 seconds, V sub 3, and so forth. So in many cases you will always have one initial velocity, and that will be V naught. But there are many other instants that you might be looking at, and you designate that by the time interval. So you can be like, okay, at 4.5 seconds, that'd be V sub 4.5. It's easier to do it that way than if you had V final, V sub f, and then you had to have another V sub f, and then another V sub f. So that's why I do it this way. But if you choose to use V sub I and V sub f for now, because it seems to make more sense to you, that's perfectly fine. So what do we really mean by velocity? I mean, we know it's speed with a direction, but what does that look like mathematically? I mean, after all, physics is applied math to a large degree. So if you recall from middle school, the equation of rate times time equals distance, and I left time as green because we used green for t earlier. Rate times time equals distance. we can rearrange the equation so that we solve for rate and we get rate equals distance over time. Very simple, you've done that before. Now, if we take rate equals distance over time, and we know that rate is simply another word for speed, we can say speed equals distance over time. And that makes sense, right? Because if speed equals distance over time, that's how we get units like miles per hour. Miles over hour, right? Miles per hour. And so it follows that since velocity is speed with a direction, we can use the same equation as long as we also use a distance with a direction, which is displacement. So, if we were to get rid of speed and call it velocity, we would have to get rid of distance and turn it into displacement. So velocity, by definition, is displacement over time. Which then brings us to our next variable. Our next variable is s, lowercase s. Or is it delta x? Or maybe it's delta y. They're actually all correct, and they all mean displacement. So why does displacement have so many identities? So lowercase s is the designated variable for displacement. However, since displacement is a change in position, when we are talking about a change in horizontal position, we often use delta x. And when we are talking about a change in vertical position, we often use delta y, just like you did in algebra. If you remember, displacement is the straight line distance between 2 points. And for this unit, which is one-dimensional kinematics, we will only be concerned with horizontal motion and thus delta x, or vertical motion, and thus delta y. Therefore, although displacement is formally designated with the variable s, we will mostly use delta x or delta y when we are talking about displacement. And now we get to acceleration, which is the final kinematic variable. Acceleration is often misunderstood. When you hear the word accelerate, you think of things like the gas pedal in a car, which is the accelerator, and that's what makes it accelerate and go faster. The brakes, though, also provide acceleration in the other direction. You see, just like the gas pedal makes you accelerate and speed up, the brakes cause you to slow down. So direction, that means acceleration is a vector. And it is. Acceleration is absolutely a vector. Here's a little musical interlude. For those of you music buffs, Johann Strauss Jr. wrote the Acceleration Opus 234 Waltz, and we are going to hear a clip from it right now. So note how the music got faster and faster. The accelerando that was utilized in the piece specifically called acceleration. And he also had some pretty awesome facial hair. So, acceleration continued. Acceleration is a vector and therefore has a direction associated with it, just like velocity and displacement. Acceleration means speeding up or slowing down. But specifically it means a change in velocity with respect to time. Mathematically, what that looks like is this. A equals delta v over delta t. And delta v is the change in velocity, in other words, speeding up or slowing down. And delta t is your change in your time. But again, whenever we're talking about t, we're always talking about delta t, so that delta can be eliminated. It's really just delta v over t. So SI units. We can't leave this slideshow without actually talking about the units for these 4 kinematic variables. So we will start here with the time interval. Time interval has the units of seconds. That's the SI unit. Again, I'm only concerned with SI units here on this slide. Displacement has the units of meters. Velocity, which is displacement over time, must therefore be meters over seconds, or the meters per second. Acceleration, which is velocity over time, must therefore be meters per second over seconds, which equals the meters per second, which is also mathematically equal to the meters per second squared. Now, again, these are just the SI units. There are several other time intervals. For example, you could use hours or days. Displacement, which is a length, you can use kilometers, you can use miles, you can use light years. Velocity, again, you can use nanometers per second, you can use kilometers per hour, you can use miles per hour. Acceleration, you can use meters per second, you can use feet per second. You can even use something dumb like kilometers per hour per day. It doesn't matter, but these are the SI units. And one last note, sometimes it helps to think of acceleration, because that's really the one that actually confuses people. Sometimes it helps to think of acceleration like I wrote it there, and think of it like I'm changing my speed, meters per second, every second. So meters per second. Sometimes it helps for you to think of it like that. So I hope you enjoyed this video, or even if you didn't enjoy it, I hope you learned something from it. And lastly, in the event that you are interested in listening to the whole waltz, it's not a bad piece. So here's a link to it, or you could subscribe to my channel if you're my student and you're trying to find the rest of my videos. And have a lovely day, and I will see you next video.